procedure to reach user equilibrium. So the basic idea is to use microsimulator link delay files to reroute all travelers. And if the rerouted travelers, if using this link delay file, the new set of plans are very similar to the plans that were used in microsimulator, then we say we have already reached dynamic user equilibrium. Let me say that again. So you have a plan. You put a plan into microsimulator. Then this plan is run. Then the output of microsimulator will be a new link delay file. And you put this link delay file back to router and run router again. Then you get a second plan file. This plan file, if this is very close to the plan file in the beginning, which was the input of microsimulator, then you say we have reached dynamic user equilibrium. But if they are very different, then we say the user equilibrium has not been reached. Understand? We have a tool here that has not been introduced, plan compare. The purpose of plan compare is to compare two plan files and select the plans that have significantly different travel times. So in my folder, I have 2 dot router stabilization, and we have 4 dot user equilibrium. And here, the 3 dot microsimulator stabilization will be skipped this time. So I don't want to use it this time. I want to directly jump to user equilibrium. In this folder, I only have one file called iteration.batch. And this stands for one iteration in the user equilibrium. Let me explain it. In the beginning, be very careful. In the beginning, I want you to manually copy the output in the second stage to this folder. So in router stabilization, you finally got a plan, right? You put a plan, you have to copy the plan here. Then you can run the iteration. Then you can run the iteration run it one by one. Time by time. So suppose you have a merge plan from stage 2. You copy here. Then we get link delays using microsimulator. We get link delays. These are copy, delete, move. You don't need to pay attention to that. Now then you start router. You get a new plan. Then you compare this new plan with the merged plan that you got from the second stage. And the plan compare will tell you how different they are. Let's look at this plan compare control file. This is the last one. So in plan compare, you have one input plan file. You have another plan file to compare. And the output will be their difference. For the difference, you have several parameters to specify. First, you can specify at most only no more than 10% will be selected. And to select the plans must have time difference between those two files. So for example, if they have 10% travel time difference, then they will have 50% probability to be selected. Okay, so this is the key, 10% time difference. Now, still using this tool, as I mentioned, in router stabilization, the final output is stored in this output folder. And we copy it and paste it to plan preparation sort input. Otherwise, the program will not run. And we'll go to step 4. We can run iteration once. Let's see the result. Now, you can see microsimulator running. At the bottom, scale it. And you will see this program runs very slowly. So it's processing the time of day now. See it? So the simulation process is the longest, the most time-consuming process. The router runs very fast. Plan merge runs very fast. This one is the slowest. And this should not be true. So the result of a plan compare is that all of them are with nearly equal plans, which is, I would say, is complete. It was not like this last time. Let me see why it is like this. So let me go back to the second stage. I haven't started the second stage yet. We run this router stabilization, and we have a lot of iterations. So you see, this speed is very fast, much faster comparing with the macro simulator. And make sure you are running the batch file under this command line mode. Don't just double click the batch file. You can do it, but I'm not sure if it runs well. There are two programs in Transims that I discovered this problem. One is TransImsNet, which I sent you, which is in the email I sent to all of you. The other one is called Plan Select. Okay, now I have the merge plan file from the output of plan preparation, merge, and copy it to use equilibrium input. Replace them. So it's still running. Let me save you some time by going to the homework 9. So in homework 9, I hope you can summarize the main ideas of Transim's 3 feedbacks. Answer 3 questions. What are their purposes? How are they related? And how are they different? How are they different from each other? And if you have any questions, you can read this PDF, this dynamic user equilibrium how-to, which I downloaded from their website. This is a 15-page document, and it has some figures, and it will help you, understand the DUE that I introduced today. So if you have some questions, you can refer to this PDF. I will upload it. So good. See, so now in plan compare, what do we see? We see the number of trips with nearly equal plans, 38.7%, which means almost 60%, more than 60% of the trips are with not equal travel times. That's the first iteration. So in order to run the second iteration, you just run iteration.batch again. So we still have some time. Let's observe this user equilibrium together. Last time it was 38% something. This time it's 48% something. So this means what? This means there are a bigger number of trips that have almost the same travel time. We use 10% as the criterion. So 50% of them are having less than 10% travel time difference. And if we run this iteration file again, Let's see what we can get. If your ArcGIS is working, then you can generate a snapshot, and you can watch them moving, the vehicles moving. So last time it was 48%, now it's 58%, right? So this number is increasing. If I run again, hopefully this time it will be 100%. Finally, we somehow reached user equilibrium because 100% of the trips are with nearly equal plans. Okay? So after this step, we can say the network has reached dynamic user equilibrium within 10% time difference. Okay? The output is also stored in this folder called plan preparation _ merge. And you take the output, you can copy the output to ArcPlan's input folder, then you can run ArcPlan. And the snapshot of micro simulator is stored here under the output of micro simulator, and you can copy it and use ArcSnapshot to visualize it. And that's all. Thank you. So, for some of you who came here late, here's a slide, so you may want to take a look at it. Okay, thank you very much.